All right, y'all, here we go. Let's check out another dude where we're going to be given some angles on one side and how this works with the law of sines. And this time, a lovely diagram is given. So here we go. So a bridge is to be built across a small lake from a gazebo to a dock. So here's the gazebo, and here's the dock. So they're going to build a bridge right here, all right? And the bearings from the gazebo to the dock is south, 41 degrees west. We're going to learn more about this later on, but let me just give a brief overview. I mean, this is why the picture is given to us, but later on we're going to have to draw this ourselves. But if it says the bearings from the gazebo, so we're starting at the gazebo to the dock, okay? Watch this here. So meaning it is south, meaning we draw a line going down south 41 degrees. So we're going to go over 41 degrees, but which way though? Well, we're going to go west. And remember, never eat shredded wheat or never eat soggy waffles, right? Remembering that? So that means this is south 41 degrees west, and I go left and see how it's connecting to the dock right there. So that's what that angle represents, okay? Now from a tree 100 meters, from the gazebo, so here we have this distance right here. The bearings to the gazebo and the dock, okay, so check this out, are south 74 degrees east. So that means south 74 degrees east, and this we're going right because east is to the right, and south 28 degrees east respectively. And you know that the whole respectively just basically means that it's referring to first the gazebo and then the dock, meaning like it's in that order because the problem gave us gazebo dock, which means gazebo and then dock right here. Okay, so we have this picture given to us. So we're supposed to find the distance from the gazebo to the dock. Okay, so that is our goal, which is to find X right here. Okay, so let's see what we know and what we can find out here. All right. Well, this is nice right here, 74 and X, meaning that's going to be one of our law of sines. Sine of 74 degrees over X. Okay, but the problem is we don't have a degree here and then a side, and we need a degree here and then a side. Oh, well, we have a side right here, right? So doesn't it kind of make sense? If we can figure out what this angle is, then we could go ahead and use this proportion. And we're going to have to because this is the only side given to us. So like I know that this is going to be 100 meters. So we just have to figure out what is this angle right here. Okay? That's our goal right now. Well, if this whole thing is 74 degrees, and if this is just 28 degrees, wouldn't it make sense that this angle right here, just this, wouldn't that be 74 degrees minus 28 degrees? Right? I mean, that makes sense, right? So this thing we can see, or we can write this right here as 46 degrees. Okay? 74 minus 28 will give us 46. Okay, so we're on a roll. If I can find this angle, then I can do my three angles in a triangle to get this missing side. So let's see what we have over here. So we have 41 degrees down here. And, interesting. Well, I got to take us back a few years to our geometry days. So let me just draw a little diagram real quick. Okay. I'm going to try to draw this very, very similar to what we have here. So think of these vertical lines right now. I'm going to go ahead and draw some vertical lines. We have that vertical line right there. Try to make them up and down right there. And we have another vertical line right here. Okay, so basically I just redrew these vertical lines. I just drew them really long there. And then we have what we call a transversal, meaning a line that cuts through both of them. So that means I'm going to draw this line right here that just cuts through them. Okay, and it cuts through. Okay, so all I did was I just redrew this dotted line, and then I redrew this dotted line, but I did it is a solid line, and this is called a transversal. So we have two parallel lines. How do you know that they're parallel, Mr. McCaffrey? Well, because if they're both south, if they're both vertical, and I know that they're both vertical because it said in the problem that they're south, I can put these little markings that means that they are parallel lines. And this line is called a transversal. Now, remember back in geometry, we learned that when we have two parallel lines cut by transversal, these angles right here have a specific name. Those angles are called corresponding angles. Corresponding angles. And do you remember what is significant about corresponding angles? That's right, little Billy. Corresponding angles are congruents. They are congruents. So whatever this angle is the same as this angle. Okay? So picture this with me. Watch this now. Isn't this right here the same as this whole thing right here? The whole thing. Remember, this is the vertical angle, and it goes, or the vertical line, and then it goes across. So this whole thing, let me just erase this here so we're not getting confused by all this craziness. Okay. Does it make sense that this whole thing is 74 degrees? So that means I can label this right here as 74 degrees. Okay. Well, if this is 74 degrees, then this must be what? 74 degrees. Oh. So that means if I were to extend this line out, so just kind of extend this out like this, okay? Then that means I can think of this right here, from here to here, okay, this whole thing, from here to here is going to be 74 degrees. Let's see here, 74 degrees. And now we know that any straight line gives us 180 degrees, right? So that means that I can say x plus 41 degrees plus 74 equals 180, right? X plus 41 degrees plus 74 degrees equals 180. Okay, and then I can subtract 74 and subtract 41 from 180. Okay, and our x here is going to be 65 degrees. So that's what I can put right here now for x. I can put 75 degrees. So a little bit of review there, or a lot of review from geometry. Parallel lines cut by transversal, corresponding angles. So that's how I got that there. Okay, well now we can actually find our missing angle that we need. Okay, we can go ahead and replace this then. If I add 46 and 65 and subtract that from 180. So if I do this right here, I'll just show you. So if I do 180 minus 65 degrees plus 46 degrees, okay, that's going to give us 69 degrees. No, it's not 69. Let's see. Yeah, it is. 69. Yeah, that is. So 69 degrees. Okay, so that's what's going to go up here. Sine of 69 degrees. Woo! Okay, so now we can actually solve now. And maybe I could just kind of do the work down over here. Or maybe I'll just kind of drag this guy down here. So we'll just take this guy, drag him on down. Oops. All right, so let's go ahead and solve this then. So I cross multiply. Okay, so that means I get x times sine of 69 degrees equals 100 times sine of 74 degrees. That means I'm going to divide by sine of 69. So x equals precisely 100 times sine of 74 degrees all over sine of 69 degrees. But that means that my answer approximately, because we're going to round now, we're just going to round it to a nice number here because we're actually finding a length of a side. We're not going to get decimals here, will be 77 meters. So that's exactly what we were trying to find. So x right here is 77 meters. That's how long the dock is going to be.